All right, tonight we're going to focus on the laws of exponents. And it says and scientific notation, but we're actually not going to get to the scientific notation until a little bit later. All right, the first thing I'm going to look at is, for example, and you're used to seeing this, if I have 4 squared, you know now that that's just simply 4 multiplied by itself. So you have 4 times 4, which is going to be 16. Not a problem. That's something you're familiar with the exponents that we've been doing in class. But now, what if, for example, I'm going to use that same thing, and I'm going to say 4 to the negative second power. Well, if I say that now, it does change a little bit. In this, what I have to use the reciprocal, which means I'm going to flip it upside down. So picture this one as saying 4 squared like over 1 if I wrote it in fraction form. Well, if I use the reciprocal, that means I'm just going to flip everything. I'm going to rotate it around. So now it's going to become 1 over 4 squared. So in this case now, in order by moving it use reciprocal, I can now make it positive. So now, when I actually square the 4, I end up with 1 over 16 as my solution. It started out as 4 to the negative second power. So now, what if I happen to have a fraction? Well, in that case, let me use this one. I'm going to use 2/3, and I'm going to raise it to the 4th power. Well, in this case, I'm just going to simply take the numerator and the denominator and do the same thing. For example, I will have 2 times 2 times 2 times 2 over, then I have 3 times 3 times 3 times 3. Well, in that case, I should end up with 16, because 2 times 2 times 2 times 2 is 16 over, when I multiply 4 times by itself, I get over 81. So in this case, I actually end up with 16 over 81. Now, these are just your basic talking about exponents, if I have a positive, negative, or if I have a fraction. All right, now, on this other side of the foldable, we're actually going to deal with operations using exponents. Now, this is what you're going to start to see a lot more of. For example, I'm going to start with the multiplying. For example, and I'm going to do a couple of these. There's a couple different ones I want to show you. For example, if I have, say, 4 to the 5th power times 4 to the 3rd power. What I notice here, I have the same base number. So all I want to do is I'm going to keep it, because I'm going to bring it in here, 4, and then, because it's the same, and then I'm going to add my exponents. So I'm actually going to say 5 plus the 3. So it'd be 4 to the 8th. Again, same base, add the exponents. So it'd just be 4, and then I can put in little parentheses just to give you a picture, 5 plus 3. And that's going to give you 4 to the 8th power. Or then from that point, if you want to raise 4 to the 8th power and you can get the bigger number that it actually is. Either one is completely right. So now, what if you have something different? What if I have, and let me change colors, what if I go with, I'm going to say negative 3x squared times 4x to the 5th. Now, this looks ugly, and it looks like it's going to be a lot more difficult, but it's really not. The process stays the same. I'm going to take my base numbers, and I'm just going to say negative 3, and I'm going to multiply it times the 4, and I have 4. So that's multiplied. And I remember, if I multiply my base numbers, I'm going to add my exponents. So from here, then it's just going to be, and I'm going to put in parentheses, 2 plus 5. Well, in this case, negative 3 times 4 is negative 12. 2 plus 5 is to the 7th. So I actually have negative 12 to the 7th power. So there was really no difference. If the base numbers are different, you just multiply them. And then I just added my exponents. The rule stays the same when I am multiplying. I want to make sure I multiply my base numbers unless they're the same. Then I can keep it. And then add my exponents. But what about if I have to divide? What if they want then? Well, if I'm adding when I multiply, that means when I divide, I'm just going to do the opposite. So here's another example. What if I have, and I'm going to use variables, I'm going to say y to the 5th over y squared. And I probably need to make that darker. So let's go ahead and go go over it just a little bit. Well, if I added when I multiplied, so when I divide, it's going to be the exact same. If my base numbers are the same, I'm going to keep it. So I'm going to have y, and then I'm going to subtract my exponents. So I'm going to put 5 minus 2. So really here, I'm going to end up with y cubed as my solution. Because when I divide the bases, I'm going to subtract my exponents. Just the opposite of multiplying. Multiplying, I add. Divide, I'm going to subtract. Now, remember, let's go back to that rule talking about the negatives. So I'm going to let me go here. I'm going to draw a line and kind of add here. What if I had, say, x to the 5th over x to the 8th? Nothing changes. Here, it's going to be x, and then I'm going to put 5 minus 8. Well, in that case, I would end up with x to the negative 3rd, because 5 minus 8 is negative 3rd. But in order to make that positive, remember, I have to use the reciprocal. So it's really going to be 1 over x cubed. Again, all this looks crazy, but really it's all the same. When I divide, I will subtract my exponents. When I multiply, I'm going to add them together. So now, the last thing we're going to cover, power to a power. What if I see this? I'm going to just go ahead and say I have 2x, and I'm trying to keep the numbers pretty simple, 2x squared cubed. In that case, I'm going to simply, my base number, I'm going to go ahead and cube it because it's saying cube everything in here. So I'm going to say 2 times 2 times 2. It's going to be, you got 8, and then I have x. Now, here, x squared, when I have a power to a power, I have exponent to an exponent, I'm going to multiply. So I have 8x to the 6th power. And that is, when you're raising a power to a power, I will multiply the exponents. Notice I didn't multiply the 2 times the 3. I actually raised it to the 3rd power. But again, the exponent to the exponent, I will just simply multiply it.